Hello, I am Ayush Gupta and I am currently pursuing my bachelor's in technology in mechanical engineering from Zakir Hussain College of Engineering and Technology, Aligarh Muslim University, Aligarh.
Welcome to this presentation on predictive maintenance and machine learning. And today's rapidly evolving industrial landscape, the need for efficient maintenance practices has never been greater. Predictive maintenance powered by the machine learning algorithms offer a active approach for maintenance that can be revolutionize how organizations can manage their assets. And by their emerging data analytics and predictive modeling techniques, businesses can anticipate equipment failures before they occur, reduce downtime, and optimize the maintenance schedule for maximum efficiency. And we in this presentation we will explore the principles and applications of the predictive maintenance with the machine learning algorithm. And we will delve into the real world examples and demonstrate the data processing technique and also discuss the technique and strategy for evaluating and improving model performance. And so now let's start. Firstly, to say firstly, we talk about the traditional versus predictive maintenance. As in the history, like historically, the maintenance has been approached in a reactive and preventative manner. The reactive maintenance involve addressing the issues they arrive, often leading to unplanned downtime and higher repair cost and preventive maintenance, on the other hand, relies on scheduled inspections and maintenance regardless of equipment condition, which can be efficiently and the costly, obviously. So these traditional approaches lack of foresight and efficiency offered by the predictive maintenance. We will go like a flow chart if we have. Like firstly, we do data collection and data pre-processing, and then feature engineering, like then model training, and then deployment of it, and then we can talk about the benefits of and the other part of this topic. Uh, Firstly, we has imported the pandas as PD. So this is commonly used for data manipulation and analysis in Python, and it provides data structure and function for efficiently handling like data structure. And this the second sklearn model selection is imported as it is a function from the model selection actually, and it is a module of a SKIT learn library, and the turn task split is used to split the data set into the training and the testing data. Crucial step is evaluating machine learning model, and then then we have imported the random forest classifier. This is a model for machine learning. The random forest classifier, the class from the sklearn assemble module. The random forest is an assemble learning method that builds multiple decision trees during the training and the output of the class. That is the node of the class of the individual tree. And this approach result in a very robust and accurate classification model capable of handling complex data set with the highest like dimensionality. And random forest is known for its resilience to overfit and its ability to capture non-linear relationship between feature and target variable. And by combining the prediction of multiple decision trees, random forest delivers superior performance compared to any individual tree. and making it a popular choice for clarification task across the various domains. And now talk about the next one. Now we have this line from the scale that metric and import score and precision score. And this line imports various classification metrics from the learns metrics module. And these metrics provide insights into the performance of clarification models by quantifying different aspects of the predictions. Accuracy measures the most uh, measure the proportion of correctly classified instances, providing an overall assessment of model performance. Precision indicates the proportion of the true positive predictions among very positive prediction made by the model, emphasizing the model's ability like to avoid the false positives. And recall measures the proportion of the true positive prediction among all the actual positive instances in the data set. Like it will highlight the model's ability to capture all the relevant cases. So, like F1 score computes the harmonic mean of the precision and you know, and offers a balanced measure model's performance. And the next ROC AUC score is evaluates the model ability like to discriminate between the positive and negative classes across the various thresholds and to provide a comprehensive assessment of its like predictive power. And the last we have as import simple imputer. Like the simple imputer is a processing technique used to handle missing values in the data set. And the missing data is a common issue in the real world data set and can adversely affect the performance of machine learning model if not addressed properly. So it will replace the missing values in a specified strategy such as the mean, median, and the most frequent value mode. And by imputing missing values, the simple imputer ensures that the dataset is completely and ready for further analysis and model. So now we have um, one data uh, given by the department like predictive maintenance.csv. Uh, this is the file reading file function and read.csv. So by loading the data into a data frame, we can easily manipulate and analyze it using the pandas and extensive set of methods. And now this line, the feature selection. Uh, the line select the target variable failure from the data set and assign it to the variable y, and the target represent the binary outcome to be predicted by the model, 0 for the non-failure and 1 for the failure. And in the predictive maintenance, the goal is to predict device failure before they occur, allowing proactive maintenance action to be taken to prevent downtime and costly repairs. And by the modeling, the relationship between the input features like x and the target variable y, like relation between the x and y, the predictive modeling can be learned patterns and make prediction about the likelihood of the device failure based on the telemetry readings and the other relevant metrics. So this line uh, a random forest classifier model with specific hyperparameters. The random forest is a assemble learning method that binds multiple decision tree during the training of the output. And this N estimators. Parameters specify the number of trees in the forest, which is a higher number generally, resulting in better performance, but also increased computational cost. And in case of like 100 decision tree will be created to form a random forest, and the random state parameter ensures the uh, reproducibility by fixing the random number generator seed. So the results are consistent across the multiple runs, and fixing the speed is essential for reproducibility and enables other to replicate that the same model. So this model dot fit will show like during the training process, the model learns the underlying pattern in the data by constructing multiple like decision trees based on the random subset of training data and features. Each decision tree is like trained independently on a bootstrap sample of the training data, and the final prediction is made by the aggregating the prediction of the all the tree in a forest, and by fitting the model to the training data, the random forest learns to capture complex relations between the input feature and target value variable, and making it well suited for classification tasks such as detecting device failure in a predictive maintenance scenarios. Actually, the utilization of random forest classifier is predictive maintenance model hold significant owning in the robustness, versatility, and superior performance in handling data like complex data sets. And random forest is chosen for like predictive maintenance due to the availability of the handle high dimensional dataset with the numerous features and observation which are like often characteristic of telemetry data. And one of the advantages of the random forest is it is inherent ability to mitigate overfitting. Like a common challenge in machine learning models, particularly in the complex dataset, the aggregating prediction from the multiple trees and introducing randomness during the tree construction through bootstrapping and like featuring subsampling. So the random forest reduces the risk of the overfitting. And moreover, the random forest is a less susceptible to outliers and noise in the data compared to the other algorithms. And another advantage can be that it has capability to provide insights into feature importance, enabling practitioners to understand the relative contribution of the different telemetry metrics in predicting devices failures by analyzing feature feature important sources derived from the random forest models. Like stakeholders can identify the critical metrics that significantly include the failure predictions, guiding proactive maintenance strategies and the resource allocation also. So overall, the random forest offers a compelling solution for predictive maintenance application, combining with the benefits of assembling, learning, robustness, and the scalability. Its ability to handle complex data and mitigate overfitting and like robustness, we have talked about it, and to make it a preferred choice or predicting the device failure and driving proactive maintenance initiates for, like in various industries. So now we have imputed the data and like the fit transformation method fits the imputed to the data and transform that data set by replacing the missing value to the computed mean. And the resulting data is then converted back into the Panda data frame with the same column name as the original data set. And by imputing this missing value, the simple imputer ensures that the dataset is complete and ready for the further analysis and modeling. And the so now we talk about the model evaluation. So these are the lines for the model evaluations. First, the accuracy score measures the proportion of correctly classified instances out of all the instances in the test set, and precision quantifies the model ability to avoid false positive is that is the ratio of the correctly predicted positive observations to the total predicted positives. And recall, also known as sensitivity, measures the model's ability to capture true positivity, that is the ratio of correctly predicted positive observations to the actual positive one. And this F1 score is the harmonic mean of the precision and recall, providing a balanced measure of model's performance. ROC AUC score evaluates the model ability to distinguish between the positive and negative classes across different thresholds. And also providing a comprehensive measure uh, of a discriminative power. And so we have got 0.9991967 uh, plasma. We have got nearly 100% accuracy, and I have used one more classify logistic regression, and I got the more accurate decision by this model, and the ROC score also good. So now we are defining the confusion matrix values. We have taken true negative 500, false positive 50, false negative 20, and true positive 430. And we will create a confusion matrix plot. These lines define the components of the confusion matrix. A label that summarizes performance of the classification model, and true negatives are instances correctly predicted as a non-failure. False positive are instances incorrectly predicted as a failure, and false negative are instances incorrectly predicted as a non-failure, and the last two positive are the instances correctly predicted as a failure. So these values are typically derived from a model predictions and the actual label in the test set. So firstly, we create a plot fixed size, sixes we have taken. This line initialize a matplotlib figure with a specific size of plotting. So matplotlib is a very popular plotting library in Python. We are using for creating static and animated can visualizations. By specifying the figure size, you can control the dimension of the plot. So the next thing we are showing. This is creating a image of the confusion matrix using the matplotlib im.show function. The confusion matrix is represented by 2 by 2. We are showing it with a true, negative, and because we have four things like true, negative, false negative, and the true positive. Okay, so we have arranged these values accordingly. And the blue color map we are used to map the values to different shades of blue, providing a visual representation of matrix. The nearest interpolation method ensures that the plot pixels are displayed without any interpolation, preserving that the exact values of the matrix. Okay, so we will see the Uh, uh, Now we have here a for loop. This is for the add text annotation. So the nested loop iterate over the like rows and column of matrix, placing text labels at the each metric position. The labels are numerically values of confusion matrix components. Like these are the four components we have, ensuring that the plot provide a clear representation of the matrix components contents. uh, the text is centered within the Excel, and we have this map, this graph, sorry. Now these first two lines are actually labeled for the X and Y axis of the confusion matrix. We are plotting. The label represents predicted and the actual class label corresponding to the columns and rows of the confusion matrix. And by providing the labels, the interpretability of the matrix will be, understandable. And so in the next three lines, like X label, Y label, and the title. So we are showing the plot. So we have by these functions plot dot color bar and grid, and these are the used function for the graph. So like for this graph, uh, the confusion matrix allows stakeholders to assess the model performance in terms of like accuracy, precision, and recall and other evaluation metrics. It provides insights into the model ability to correct, classify, and instances and identify areas like for improvement, obviously. And instance, a high number of false positives may suggest the need to adjust the model threshold or like fine tune a parameter to reduce false alarms. And conversely, a high number of false negative may indicate the necessity of the enhancing the model sensitivity to detect true positive. So overall, the confusion matrix serves as a valuable tool for evaluating the performance of a classification model of this. So it will enabling like stakeholder to understand the model strength and weaknesses in predicting device failure accurately. The facilities informed decision making regarding maintenance strategies, resources allocation, and risk mitigation. Efforts based on the model prediction and associated. So now we can move to the like for benefits and the future direction of this method I've used. So it will have a certain benefits and you can get some directions maybe. So first is the enhanced accuracy. So random forest algorithm is chosen for its capability to handle complex datasets with the numerous features and observations effectively. And unlike the other decision models, random forest aggregates prediction for multiple trees, reducing the risk of overfitting and improving generalization to the unseen data. And the algorithm's ability to capture non-linear relationship and interactions among the features enhance the model predictive accuracy and making it well suited for identifying subtle pattern indicative of impending equipment failures. And the second uh, is the proactive maintenance approach. Like the traditional maintenance strategy often rely on the reactive approaches, where the maintenance is performed after equipment failure, uh, leading to costly downtime and repairs. And our predictive maintenance model shift the paradigm by enabling proactive maintenance and by like analyze historical telemetry. If we analyze it, like the data in identifying early warning signs of the equipment degradation, the model predict failure before the manifest. And the proactive approach allows organization to schedule maintenance activities during the planned downtime, minimizing the disruptions to operations and optimize resource utilization. And the third is the cost saving and reduced downtime actually. Predictive maintenance offer substantial cost saving by preventing costly unplanned downtime and emergency repair. By addressing maintenance issues before they escalate into the failure, organization can avoid the production interruptions and associated revenue losses. And additionally, I can say predictive maintenance helps extend equipment lifetime by addressing issues only, reducing it will reduce the frequency of the costly replacement and prolonged asset longevity, I guess. Furthermore, I can say by optimizing maintenance schedules based on the predictive insights, organizations can minimize unnecessary maintenance activities and associated labor and material costs, resulting the overall operation efficiently improvements. And the last and fourth, the customizability and the scalability. Our predictive maintenance model is highly customizable actually to accommodate the diverse need and requirement of the different industries and the equipment types. So, like you users can tailor a model by selecting relevant features, adjusting the model parameters, and incorporating domains specific knowledge of to improve predictive performance. Moreover, the model's scalability ensures that it can handle large volumes of telemetry data generated by a wide range of equipment uh, types of operating environment. And with this ability to scale like horizontally across distributed computer resources, the model can process massive data set efficiently, I guess, making it a suitable for the whole big organization with varying data size and the computational needs. And by leveraging our predictive maintenance solution, organization can achieve enhancing accuracy in predicting equipment failures, adopt a proactive maintenance approach to minimize downtime and cost, and customize a model to suit their specific operational requirement. And with the potential for significant cost saving, operation efficiency improvement, and enhanced asset reliability, our solutions offer a more comprehensive framework for the driving predictive maintenance initiates across the big industries. As we are on the last part of the hackathon, I want to take a moment to express my sincere gratitude. The endeavors has been a solo expedition, but it has been fueled by passion, determination, and the unwavering commitment to pushing the boundaries of the machine learning. And this journey has been a testament to the power of self resilience, I guess. And I am filled a sense of pride and accomplishment. Actually, it is a solo journey I have done so far. We have developed a model. So, thank you so much, everyone, and thank you for me. So, thank you.